This lesson is on special products of polynomials. A few sections ago, we looked and found what x cubed meant. So x cubed, since there's a 3 up top on the exponent, that means we're multiplying x times itself 3 different times. We're going to use that same logic when we look at polynomials. So if we have x plus y squared, there's a 2 up in the exponent, so that means we're going to take x plus y times itself 2 times. The first property we're going to look at is if we have a plus b squared. So this is called square of a sum because we have addition inside of our parentheses. So this equals a squared plus 2ab plus b squared. And that is the square of a sum. We will FOIL it out to see that when we FOIL it, we do in fact get this answer. So we have a plus b times a plus b because it's squared up top here. So then we're going to take a times a to give us a squared plus a times b plus a times b. And remember, with multiplication, the letters can be in any order. So I could have written b times a rather than a times b. And our last one is going to be b squared. Then, of course, we need to simplify and add our like terms. And we end up with a squared plus 2ab plus b squared. And that is, in fact, the same answer that we had at the beginning. So you can either choose to remember the identity, or you can always just distribute it out, whichever you would prefer. So now we're going to do an example. So we're going to do 2x plus 5 squared. And remember, since it's squared, that means we take 2x plus 5 times itself 2 times. And then we have 2x times 2x giving us 4x squared plus 10x plus 10x again plus 25. Add our like terms and we get 4x squared plus 20x plus 25. Now if you remember, we could use our identity, which was a squared plus 2ab plus b squared. So in this problem, a would be 2x and b would be 5. So 2x squared
up to 32
plus 2 times a, which is 2x, times b, which is 5, plus b, which is our 5 squared. Simplify that out, we get 4x squared plus 20x plus 25, which is the same thing we got when we distributed it out. Another identity is square of a difference. So this is when we have a minus b, so instead of a plus b in the parentheses, this time we have minus, and it's squared, and that equals a squared minus 2ab plus b squared. Now if you notice, the only difference between the square of a difference and the square of a sum is that with the square of a difference, we have a minus 2ab, and with the square of a sum, we had a plus 2ab. And we're going to FOIL this out to check and make sure this actually works. It should be a minus b, there we go, squared. Remember, since it's squared, we take a minus b times itself 2 times. A times A gives us A squared minus AB minus another AB. And remember, minus B times minus B is going to give us a positive B squared. Simplify that out, and we get A squared plus, minus 2AB plus B squared, which is the same thing that is up here at the top. Let's do an example. So we have 3x minus 1 squared. And let's first distribute that out, and then we will use our identity to check and make sure we get the same answer. So we take 3x times 3x, which gives us 9x squared, times plus 3x times a negative 1, which is a negative 3x, and then negative 1 times 3x, another negative 3x, and negative 1 times negative 1 is going to give us a positive 1. Combine like terms, 9x squared minus 6x plus 1. Now if we want to use our identity, which if you remember, it's a squared minus 2ab plus b squared. So in this case, our a is 3x and our b is 1. Notice it's not the negative 1, but just the 1, because we're dealing with the sum of a difference. So a squared would be 9x squared minus 2 times a, which is 3x, times b, which is 1, plus 1 squared. If we simplify that, we have our 9x squared minus 6x plus 1, which is the same thing that we got when we distributed. And the last identity is difference of squares. So this is where we have a plus b times a minus b. Notice how the first set of parentheses has a plus in there and the second has a minus. And this equals a squared minus b squared. Also notice how there's no ab term in the middle like the square of a difference or a square of a sum. So just like the other ones, we are going to distribute this out to see if we do in fact get a squared minus b squared. So first we take a times a, giving us a squared. Then we get negative ab. Then we get a positive ab. And then a negative b squared. Now look here in the middle, we have negative ab plus a positive ab, so those are going to cancel each other out, leaving us with just a squared minus b squared. Now we'll do an example. So we are doing 2x plus 3, so then the other one is 2x minus 3. Notice that our a's have to be the same in both. Both of them are 2x, and our b's are both 3. The only thing that is different in the two parentheses is the first one is plus, and the second one is minus. So now we will distribute. Take our 2x times 2x, giving us 4x squared, and then 2x times negative 3, which will give us a negative 6x. 3 times 2x, positive 6x, and then positive 3 times a negative 3, which will give us a negative 9. We now have to simplify and combine like terms, leaving us with 4x squared. These 6x's are going to cancel out, so we are left with minus 9. Now, if we wanted to use our difference of squares property, remember that equals a squared minus b squared. Earlier I said a was 2x, so we have our 2x squared minus, and our b is 3. So then we have 3 squared. When we simplify that, we get 4x squared minus 9, which is the exact same thing we got up there. So for all of these, you can either choose to remember the sum of the squares, sum of the difference, and difference of squares, or you can always just distribute them out. As you've seen, they will give you both the same answer.